And 2.7 is on what is called inequalities, okay, which means instead of one side being equal to the other, like what we've been dealing with the equations, one side is going to be either less than or greater than the other side, okay? So before we get into talking about these, all of the answers, or a lot of the answers, are going to want your what's called interval notation, and it's going to want you to put your answer in that way. Interval notation has some kind of opening symbol and some kind of closing symbol. Then there will be inside here the beginning of the interval to the end of the interval, and this will start to make more sense once we get into these. Now, the two different kinds of symbols that you're going to see are parentheses and brackets. So let's talk about what makes the difference here. Now we're going to see there's 4 different symbols talking about less than and greater than, okay? That symbol would mean this side is less than this side. This symbol means this side is greater than this side. If you see a less than or greater than symbol and you transfer that into interval notation, that is actually going to use a parenthesis around that number. This symbol still has the less than symbol like this one, but it has this half equal sign right here. That means that symbol says less than or equal to, and just like that over here. Greater than or equal to. These two, if you have the equal to bar, that is when you are going to use a bracket around that number. So no equal to sign is a parenthesis. If it's got the equal to thing below the arrow looking thing, that means you're going to use a bracket. Okay? All right, now let's talk about the number line. All right, we have a number line. Right in the middle of the number line is 0. All the numbers on the left side of 0 are below 0 or negative, right? That's what it means to be below 0. That means you're a negative number. So all of these numbers here would be going negative. The numbers to the right of the 0 are your positive numbers. When you're going, this arrow right here means this number line actually goes forever. It doesn't have a stopping point. Okay? And when we talk about going one way forever, we are going infinity amount of numbers. So when you're going to the left side of the number line, it goes all the way to what's called negative infinity. And the symbol for infinity is this sideways looking 8. So it goes forever to the left to negative infinity, and it goes forever to the right to positive infinity. And again, infinity is not a number. It just means keeps going on forever and ever. So the first couple of problems are going to give us a number line, such as this, and then it's going to have a symbol, either a bracket or a parenthesis on a number with an arrow going one way. So let's look at one like number 1. I'm actually just going to leave that number line up there. Number 1 says, write an inequality that corresponds to the graph of solutions on a number line. And it's got an open parentheses on negative 11. Let's see, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the number negative 11, and it's got an open parenthesis with the arrow going to the right. It wants us to write the inequality that corresponds to this graph. Hang on, let me see if it wants it in interval notation or. Okay, so this one just wants it to write it as x is greater than or less than or greater than or equal to or less than or equal to this number. So if I have an open parenthesis, first of all, is that going to give me a bracket or a parenthesis? Just like what it is. If it's a parenthesis, when we're not even doing interval notation yet. So let's just talk about this. What would the parenthesis mean it came from? Did it come from this or that? Do I need the equal to bar? What does a parenthesis mean? It means just the greater than, right? Not greater than or equal to. If it was greater than or equal to, it would have had a bracket around it. So if the arrow is going in this direction from negative 11, where are the numbers doing? Are these numbers that are this way, are they greater than negative 11 or less than negative 11? All of these numbers this way are greater than negative 11, right? The numbers less than negative 11 would be to the left of it. So you can kind of think of it as that. Less than would be a left arrow, less than left. So when I'm writing this as an inequality, that means all the numbers in this side of negative 11 are greater than negative 11. Okay? Number 2 is the same kind of problem. It's going to have a number line with a symbol on a number with an arrow going in one direction and ask you to write the inequality that it's talking about. Let's say 0 is here. This time the symbol is on positive 11. So I'm just going to act like there's 11 spots there. This one has a bracket on 11 with an arrow going to the left. So let's see. A bracket means my inequality is going to have that equal to symbol, right? That's what the bracket means, is it's going to have the equal to symbol. What are the numbers that are to the left of 11 on the number line? They are less than it, right? So that's what I want to do. I want to say X is all the numbers less than, since it's a bracket, or equal to 11. That's what that arrow means. This arrow covers all the numbers less than 11. All right, number 3 says write the inequality X is less than or equal to 7 in interval notation, and then draw it on the number line. And then actually, you're not really going to draw it on the number line. It's going to give you multiple choice and pick which one it is. So I'm actually going to do this part first. I'm actually going to draw it on the number line first. And then I'm going to use that picture to write the interval notation. I'll show you what I'm talking about. I think it's easier to see the representation on the number line, because then actually when you're transferring from the number line to interval notation, you actually see the picture on the number line. I'll show you what I'm talking about. So it wants me to do the inequality X is less than or equal to 7. So let's see, let's just draw this on the number line. So here's my 0, 7 would be somewhere right over here. There's my positive 7. All you need to know is where this number is on the number line. So where would the number, first of all, am I going to use a bracket or a parenthesis? I'm going to use a bracket. Right? It's got the equal to bar. You are going to use a bracket. Where are the numbers less than 7? Are they to the right of it or to the left of it? Less than means left. So my arrow is going to go to the left. And I'm going to have a bracket on the 7. Your bracket will go the same, it'll point the same direction as that arrow. So that actually answers the number line part of this question, right? You'll notice that it says to write the interval notation first and then pick the number line that it goes with. I like to actually do this part first. So now what am I looking for in that? I'm looking for a bracket with an arrow to the left. So what I would do is, first of all, come in and get rid of A and D, because they both have parentheses, which means I know that it's not A or D because they don't have a bracket. So then I'm looking at B and C. So then the difference between B and C is the way the arrow's going. They both have brackets. I just need to get my arrow going in the right direction, which is left. Now, once you have that picture, your interval notation, which remember, we talked about interval notations have symbols, an opening symbol and a closing symbol. You can actually pull it directly off of this number line. There's my closing symbol, the one that's going in this direction. There's a closing symbol with the 7, which means I need the opening symbol. This arrow means it's going forever this way. All the numbers less than 7 means all these numbers forever. And where does this go to forever? If I'm going forever this way, it goes to negative infinity. So negative infinity is actually your opening. Infinities, no matter if they're negative or positive, are always parentheses every time. So these three things say the same thing. X is less than or equal to 7. This means there's a bracket on the 7 with all the numbers this way. That's all the numbers less than 7. This also means all the numbers less than or equal to 7, because if I'm less than 7, it doesn't tell me what I am. I'm just every number less than 7, which means going all the way to negative infinity. So that's why I like to do the number line first, because once I do that, do you see how I just literally pulled this bracket off the number line? And then I had to think about what my opening symbol would be. If you've got an arrow that's going forever, your symbol is going to be an infinity, whether it's negative or positive. Okay, let's look at number 4, same kind of problem. X is greater than 10. So again, we're going to put it on the number line first. So let's see, on my number line, what I pretty much like to do when I'm just drawing my own number line is put a 0 and then put where that number would be. So 10 is going to be on that side of 0, right? Because only negative numbers are on this side of 0. So let's see, this time, think about it, you want a bracket or a parenthesis. Since there's not an equal to bar, I'm going to use a parenthesis. Where are the numbers? This says, and you can kind of use this to tell you what way your arrow needs to go. Greater than means to the right. All the numbers that are greater than 10 are on this side of it, right? Because I go from 10 to 11, 12, 13. The numbers greater than 10 are that way. So I'm going to have a parenthesis with an arrow to the right. Those are all the numbers greater than 10. Every number that's to the right of the number line from 10 is greater than 10. So once I see this, then I just simply pull that directly off of my number line. So this time, this is an opening symbol, right? Opening, closing. So I'm opening at 10 with a parenthesis. And what is, again, the arrow going forever that way? This time, where is the arrow taking you? To positive infinity, right? Negative infinity would be this way. So that's my closing, 10, all the way up forever. Infinities are always parentheses.
So is that the answer?
That's the answer. It's
okay.
going to ask you first for this. So
okay.
This is what you would put right here.
All right.
Do open parentheses 10, comma, infinity. And when you're looking to put the infinity, you know, down at the bottom where you have those little things with blue boxes, like if you're going to try to type a fraction or an exponent, there will be one that is a sideways 8 on these problems. So then you would put, so that's what would go in that spot. And then it'll say choose the correct graph. So it's one of these, but you've already drawn it. Okay, we're kind of doing it out of order because I think it's once you draw, it's hard to go from here to here to here. But if you see this on the number line, look, all I'm doing, here's my 10, there's my infinity. I'm just yanking it off the number line, using the same symbol I did here, and then I know if it's an infinity, it's always going to have a parenthesis. So then, once you do that, then you're coming to choose the number line. And what I like to do is go through, first of all, if I'm using a parenthesis and not a bracket, that's a bracket, that's a bracket. So it's not either one of those. So then, once you narrow it down to the two that are left with parentheses, then you're just picking which one has the arrow going in the right direction. So I need my arrow to go to the right. which would be this one, the arrow going to the right. Okay, number 5. This one looks a little different. It'll say -9 less than or equal to x, which is less than or equal to -1. So I'm going to draw my number line. Here's my 0. I need these two numbers represented on my number line. Right? This one has 2 numbers represented instead of just 1. So put them both on the number line. Let's see. This -1 would be right here. Because then it's going where? -2, -3, -4, all the way down to -9. So if you're looking at this, just like what this looks like, this is saying x is the numbers between -9 and -1. So if it has the x in between 2 numbers, that's what you want to represent. You don't want to say going on forever to the left or to the right. You want to say x is only the numbers. Look how it's in between these 2. So my opening and closing brackets or parentheses are going to be on -9 and -1. So then you just need to tell yourself they both have equal 2 bars, which means they're both going to be brackets. Right? This is what tells you brackets. If it doesn't have that equal 2, then you're going to put a parenthesis. So a bracket for -9, a bracket for -1. All the numbers in between those numbers are these right here, right? If you're between -9 and -1 on the number line, you are in between those 2 numbers. Oh, this one doesn't even want you. Oh, yeah, it does. So this one has the graph first. So you would do the one that has the bracket. Between -9 and -1 with just taking into account the numbers in between it. And then it wants the interval notation. Well, again, now that you have the graph, you literally just pull this off the graph. Open bracket with the -9, comma, -1, closing bracket. Again, just pulling it right off the number line. Number 6 is like this one too. -2 less than x, which is less than or equal to 6. So again, this one, what's your x in between? -2 and +6. Here's my 0. And again, I like to always put the 0 just because I like to separate the graph from the negative numbers and the positive numbers. So let's see, -2 will be on this side of 0 because it's negative. 6 will be on this side of 0 because it's positive. If x is in between -2 and 6, x is all these numbers right here. That's how you be in between -2 and 6, is you literally are between them. Now I just need my opening and closing symbols. What's the -2 going to have? A parentheses, right? Because it doesn't have the equal to bar. So it's going to have a parentheses. The 6 does have the equal to bar, which means it's going to have a bracket. And that's your interval notation. Open parentheses with a -2, and then the bracket around the 6. Again, if you've drawn it here right, then you're just copying it, essentially. And again, a lot of times on these problems, it asks you to put this in first before it'll even give you the multiple choice of the number line. But remember, just because it asks for this first, doesn't mean that's what you have to do on your paper first. I would definitely do this on my paper first. All right, number 7. X minus 5 is greater than or equal to -9. What did I say? -9. So before I can do any kind of interval notation or graphing or anything like that, this X needs to be alone. Just like my equations. I want X on one side and the number on the other. So just like I do equations, I'm just going to use those same skills. So in order for X to be alone, that -5 needs to go away, which just means I will +5. If I do it to one side, I have to do it to the other. Those cancel. There's your X. Just drop down that symbol. So greater than or equal to -9 plus 5 gives me -4. Here's my 0. Again, since there's only one number in my answer, right? If there's 2 numbers, there'd be another number over here would say, you know, -10 is greater than X, blah, blah, blah. And the X will be in between 2 numbers. But only one number is represented. That's the only number you care about on your number line. It's going to have a bracket on it because it's got the equal to bar. The arrow goes in this direction. Your arrow points to the right, just like that arrow right here does. So the X is all the numbers greater than or equal to -4. Where are the numbers greater than -4? On this side of it. And like we said, since it has the equal to bar, it'll have a bracket on it. Then I'll use this number line to do my interval notations. I've got this opening bracket with a -4, with an arrow going that way. Since there's not a closing bracket or parenthesis, that arrow means it's going that way forever, and this way forever means it's going to infinity. So the closing symbol, since it's an infinity, will be a parentheses, because infinities always have parentheses. Ooh, it's heavy. All right, number 8. The inequality is 9x plus 4 is less than 8x minus 5. So now we're getting into all those skills that we've learned in the rest of chapter 2 on how to solve equations. For the most part, solving inequalities are going to be the same skills. So here's my inequality symbol. I'll just drop it down like I do my equal sign. I notice I do have x's on both sides. When I'm doing inequalities, I always like my x's, I always cancel out whoever is on the right, because I like my x's to be over here, because it's easier to read an inequality when your x is on the left of it. So I just always cancel out this one over here. So I'm going to subtract that 8x. Do it from both sides. So 9x minus 8x just leaves you with 1x, so just an x. Still drop down my plus 4. Still drop down my less than symbol. The 8x minus 8x cancels, so I still have negative 5 over here. Get an x alone, which means I will subtract the 4. Cancel it out. So here, all I have left is x. Drop down my less than. Don't mess it up here, right? If you're not liking doing that, what do you need to tell your calculator to do? Negative 5 minus 4. So again, the negative is below the 3. So negative 5, then your minus button, and then your 4 to get negative 9. So now that's what I need to represent on my number line. X is less than negative 9.
So we don't divide. Wait, I'm confused.
You only divide when you have, if there would have been a number hooked, you divide with number hooked on to the x. So I am going to in future problems, but I didn't, once I got it down to just being an x without a number hooked onto it, I didn't have to divide anything. That's when you divide, is if you're trying to get rid of a number hooked on to the x. We will get those. So here's my 0. That means negative 9 would be somewhere down here, since it's a negative number. I'm going to have a parenthesis on it, right? Because it doesn't have an equal to bar. Where are the numbers? If you are less than negative 9, that means you are to the left of it, right? Less than left. With a parenthesis on it. And you want your parenthesis going in the same direction as your arrow. Which means the closing symbol, right? Because opening symbols and closing symbols are like this. This is the closing. This is the end of it. My negative 9 is down here. What is this arrow going forever this way taking me to? Taking me to negative infinity. And what do infinities always have? Parentheses. Yes, definitely, Kayla. One more example like this, Kayla?
Yeah, because I just got kind of lost with it for a second.
Yeah. I'll do another one like this.
Okay, thank you.
This is a tricky section. A lot of people, people have a lot of troubles with the less than and greater than stuff. There's just so much that goes into every problem. There's stuff you have to remember. You got to remember whether it's going to be a parenthesis or a bracket. Is my arrow going to go to the right? Is it going to go to the left? Or is it going to be in between or infinity involved? There's a lot of stuff to remember on these. Here, I'll pause the recording and let y'all go try to. Okay, I'm going to bring this down. Again, when you notice that there are x's on both sides, I'm going to cancel out my right one. And I'm going to subtract that 5x off of both sides. So over here, I have 6x minus 5x, which just leaves you with that 1x. So I can just write that as x. Bring down my plus 7. Bring down my greater than or equal to symbol. The 5x's are gone over here. Make sure you drop down that negative with the 4. So to get x alone, I would minus that 7. So now I have, there's my x, there's my greater than or equal to negative 4 minus 7. Again, you can think about that as in your bank account. If you have negative $4 and you go down $7 more, now you're at negative 11. Or if the temperature is negative 4 and it goes down 7 more degrees, now you're at negative 11, right? Or you can put that in your calculator. So let's see, on my number line, if 0 is here, negative 11 is on this side of it because it's negative. This time, look at the direction this arrow is pointing. The same direction is going to be on your number line. This arrow and this arrow point in the same direction because this says x is greater than this number. All the numbers greater or bigger than negative 11 would be on this side of it. So now it doesn't have a bracket or a parenthesis, and that's just looking to whether see if it has that equal to bar or not. Since it does have the equal to bar, it is going to have a bracket. So this time, that's your opening symbol, right? Symbols always have opening and closing. Openings go this direction. Closings go this direction. So it's going to open at negative 11 and the arrow going forever. If your arrow goes forever that way, it's going to infinity. And infinities always have parentheses. They're not ever going to have a bracket. Okay, now let's go to number 9. This one says 3x is greater than or equal to negative 24. So for this one's x to be alone, now I do have a hooked on number. Since I do have a hooked on number, I'm going to get rid of that 3 by now I'm going to divide because it's hooked on both sides. So the 3's cancel. There's your x. There's your greater than or equal to. Negative 24 divided by 3 gives me negative 8. So x is alone, so here's what I'm going with on my number line. I'm going to draw where x is greater than negative 8, or equal to. So if your 0's in the middle, negative 8 is to the left of it, right? All the negatives are on this side of 0. Again, you can draw your arrow in the same direction as this arrow. So greater than negative 8 means this side of negative 8. Equal to bar means bracket. So the bracket goes the same way as your arrow. I'm going to have an opening bracket on negative 8. Arrow forever that way means arrow forever to infinity. So there's your interval notation. Pull it right off your number line. An opening bracket with a negative 8. And since the arrow is forever that way, it's going to go to positive infinity with a parenthesis around it. Right, number 10. This has something new that only happens with inequalities. I'm going to write it on the board before I do this next problem. If your step is to divide by a negative, you're actually going to flip your inequality symbol around. So, if you have to divide both sides by a negative, your inequality symbol will turn around. And we're going to see this on number 10.
Is the inequality like the bracket and the parenthesis, or
The inequality is this.
or is it the greater? Okay.
Yeah, that's the inequality. So if you divide both sides by a negative and your inequality started off like this, as soon as you divided it by a negative, it went to that. That's what's going to turn around. Good question. So on number 10, I have negative 3x is less than 12. So my number's hooked on, which means I am going to remove it by dividing, because we remove all hooked on numbers by dividing, and you divide by exactly what it is. So since negative 3 is what is hooked on, that is what I'm dividing by. I am if this number right here is a negative, that's when you're going to turn this symbol around. So the negative 3's cancel. There's my x. Since I divided by a negative, instead of pointing this way, now it's going to point that way. So it was pointing to the left, now it's pointing to the right. And then just do division like you always do. 12 divided by negative 3 gives me negative 4. So your solution is x is now greater than negative 4, and this is what you're graphing. So if that's where my 0 is, negative 4 is on this side of 0. All negatives are on this side of 0. My arrow points the same way as the arrow in my answer. So it's pointing to the right. It doesn't have the equal to bar, which means the negative 4 is going to have a parenthesis on it. So this says x is greater than negative 4, which means all the numbers to the right of negative 4. So this is an opening symbol. So I'll have opening with a parenthesis, negative 4. And anytime you have an arrow going forever in one direction, it's either going to be going to positive infinity or negative infinity. If your arrow is going to the right forever, that side is to positive infinity, and infinities always have parentheses. Okay, try one like that. Negative 7x is greater than 21. Try that one and I'll pause it. I didn't want to do that. So again, we divided by negative 7 on both sides. That's what made this turn around to that. When I did the division, I got negative 3. So when I put the negative 3 on the number line, I drew my arrow the same direction as this symbol was pointing, which was to the left. And I put a parenthesis on the negative 3 because it doesn't have the equal to bracket. Since the arrow, if you have an arrow going forever in one direction or the other, it's going to go to some kind of infinity. Since this one was going to the left, these are my negatives. So I'm going to go to negative infinity. And since infinities always have parentheses, I just kind of put a parenthesis around it. So when I did my interval notation, I just pulled it right off that number line. Okay, now number 11. All right, negative 2/3 x is less than negative 2. Oops, hang on, I'll fix it. Now, remember, we do have a calculator, so that's going to help us on this one because this negative 2/3 is hooked on to that x. Which means, how do you always get rid of hooked on numbers? You divide by them, whatever they are. Which means I am, since it's hooked onto the x, I'm going to divide by this exact number. If I do this side, got to do that side. So this side's not too bad. It just cancels. That's all we did it. There's my x. Is this number down here that I'm dividing by negative? Since it is, this will turn around. So instead of pointing to the left, now it's going to point to the right. This is what I'm going to put in my calculator. If you are dividing by a fraction, I would put parentheses around that fraction when you're typing it in your calculator. Because if not, it's going to think you are typing in negative 2 divided by negative 2 divided by 3. And you want to tell it to do negative 2 divided by the negative 2/3 as a fraction. So put parentheses. Again, if you have a division problem and either one of the top or the bottom of it, or both, are fractions, put parentheses around those fractions. So let's type this in exactly like we see it. So on top, I'll need that negative 2. So negative 2. And then you're divided by. Now, this is where I want to tell the calculator, I don't want to divide by negative 2 and then by 3. I want to divide by negative 2/3. I want to do that whole thing as its own fraction. So that's why I'm going to do an open parentheses, then type in negative 2 over, which will be divided by 3, and then close your parentheses. So see, that kind of tells it that this division, this division symbol is saying divide by. This division symbol is saying these two numbers are making a fraction. That's why you want these parentheses around that negative 2/3 right there. Hit enter. And good, we get a 3. We don't even get a fraction. So, is it positive? Yeah, positive since we had a negative divided by a negative. So x is greater than 3. Put that on your number line. There's 0. There's your 3. draw your arrow the same way this symbol is pointing, which means my arrow needs to go to the right. And then you're just deciding whether or not this 3 needs a bracket or a parenthesis. Since it doesn't have an equal to bar, it needs a parenthesis. Arrow going forever to the right, which means it's going to infinity. And what do infinities always have around them? Parentheses. So once you draw that on the number line, now when you are doing your interval notation, you're just copying it, right? These parentheses with a 3, comma, infinity. All right, number 12. Seven x plus 5 plus x is less than 1 plus 4x minus 12. All right, so now we're getting into some equations that take several steps to work. Ooh, 13 and 14. So, I notice I got a lot of stuff going on in front and behind my symbol. So I'm just going to drop down my symbol so I don't lose where it is. Look at the left side. I have 7x plus 5 plus x. That means I have like terms on the same side of the symbol, which means I need to clean it up by putting them together. Who can you put together on this side? You can put the 7x and the 1x together. Again, they're on the same side of the equal sign, so just put them all in the same basket. So I actually have 8 x's over here. So that put the 7x and the 1x together. I'm just dropping down that plus 5. I didn't have anybody to go with. I can do the same kind of thing over here. This time I'm not combining x's. That's my only x. So there's nobody to put with him, so I'll just bring him down. But I can put the 1 and the negative 12 together. So on the same side of the symbol, I have 1 minus 12. If you want to type that in your calculator, that's what you tell your calculator. 1 minus 12, which gives me negative 11. So that cleaned it up a little bit. Still just going to drop down my symbol so I don't misplace it somewhere. Now I'm to the point where I say, okay, I've got x's on both sides. I'm going to cancel this 4x out. So I'm just going to subtract it off. If I do it to that side, I have to do it to this side. Now I'm subtracting. You don't ever switch your symbol around unless you divide by a negative, which I have not had to do yet. So let's see. 8x minus 4x is 4x. Drop down your plus 5. Again, just drop down your symbol. The 4x minus 4x cancel, so all I have left over there is the negative 11. There's my x. I'm going to get it alone now, right? So what do I do to get it alone? The hooked on number goes away last, always, which means I need to get rid of the plus 5. So I will subtract it with a minus 5. So now you have 4x, so I'm getting closer. Still just drop down my symbol symbol. I still hadn't divided by a negative, so I haven't had to switch it around. Over here, if you want to type this in, you need to type in negative 11 minus 5, or think of yourself as negative 11 degrees and going down 5 more. You go down 5 more, now you're down to negative 16. What is hooked on to the x? A positive 4. So that is what you are going to divide by. You are not dividing by a negative. You are dividing by positive 4. So even though this number is negative, it doesn't matter. If you are dividing by a negative, this number would have to be negative, right? This is the number you are dividing by. So if I'm dividing by 4, I still don't switch my sign around. So you'll notice my sign stayed the same all the way down because I never did divide by a negative. So there's my x is less than. Now I do have negative 16 divided by positive 4. So that does give me negative 4. So x is less than negative 4. So here is what I'm putting on my number line. So there's the negative 4 on my number line. Draw your arrow the same way this one's pointing. So since it's pointing to the left, I'm going to draw my arrow to the left. It doesn't have an equal to bracket, which means that negative 4 is going to have a parentheses on it. Your parentheses will go the same way as the arrow. Since the arrow is going forever to the left, this side is the negative infinity. Infinities always have parentheses. Again, you don't need to see, this is not so, I'm just doing this so in the next step I can just pull this off as my interval notation. Right? So this is my interval notation. Negative infinity to negative 4, both with parentheses. All right, 3 more, and they are doozies. So then remember we have lab. So if you're staying in lab, I would probably work these backwards, right? The first problems were not near as involved as these. All right, 13. Now we're getting more involved. 7, open parentheses, x plus 3, close, minus 8x, less than or equal to 3 times 3x plus 1, parentheses closed, minus 7x. Okay, the first thing I see is those parentheses on both sides. Those have got to go away. I'm just going to, since again, I've got all kinds of stuff going on in front of my symbol and behind it. So I'm going to drop it down so I don't lose it while I'm working. To remove the parentheses, you distribute what's bumping up against it, which this one has a 7. And this one has a 3. So that's what I'm distributing. So let's see. Here, if I distribute the 7, I have 7x plus 7 times 3 is 21. This minus 8x just drops down, right? Because it's not inside the parentheses to distribute to. So it just comes down. Distribute the 3. 3 times 3x gives me 9x. Plus 3 times 1 is 3. Drop down to minus 7x. Again, I still get a lot going on in front and behind my symbol, so I'm going to drop it down so I don't mess it up. Now, I do see that I can actually clean up the front and the back of this by combining the like terms that are in the front and the back. Are there any x's? Here's my symbol. So I'm looking at these terms over here, which means I notice that I have x's that I can put together in the same basket. 7 minus 8. So I actually have negative 1x on this side. Because 7 minus 8 gives me negative 1. This 21 doesn't have anybody to go with, so I'm just going to bring it down, plus 21. On the right, I also notice that I have x's that can go together. Here I've got 9x minus 7x. So I'm going to put those together and just say that's 2x. Drop down your plus 3 since it doesn't have anybody to go with. So now, again, dropping down my symbol. Now, I know a lot of times when we're doing equations that have equal signs and not less than or greater than sign, we always cancel out the small x. What I like to do is if it's an inequality, which means not an equal sign, but it has the less than or greater than with it, no matter what, just cancel. If there's x's on both sides, I'm going to cancel out the one on the right. The reason is you like your x's to end up over here, which means you need to get rid of them on the back end. So even though it's going to make my x's negative, which is fine, I like to keep them in front of this. And I'll show you why in a minute, which means I need to get rid of the 2x. I'm going to subtract it off. So let's see, negative 1x minus 2x. So if you're at negative 1 degrees and you go down 2 more, now you're at negative 3x. Drop down my plus 21. Drop down my symbol. All that's left over there is 3. So here's my x that I'm getting alone. Don't get rid of what's hooked on yet. Get rid of that plus 21. So I'm going to subtract 21. Cancel it. So now all I have left over here is the negative 3x. I still haven't divided by a negative, so I'm still dropping down my symbol and not changing it. Let's see, over here, 3 minus 21 gives me negative 18. Punch that in if you don't like it. 3 minus 21. So now what am I dividing by? What is hooked on? Negative 3. So now I am going to turn this symbol around. So here, if I divide by negative 3, to cancel out the hooked on negative 3, I'll have x. I divided by a negative, so instead of my inequality pointing to the left, now it points to the right. When I do this division, negative 18 divided by negative 3 gives me positive 6. So there is my inequality. X is greater than or equal to 6. So there's your 0. Your 6 will be to the right of it. All right, when you turn your symbol around, now it's pointing to the right, which is the same direction your arrow points. These two things point in the same direction. Six Since it has the equal to bar, it's going to have a bracket on it. I've got a bracket as my opening symbol. The arrow goes forever, which means it's going to go to infinity, and infinities always have parentheses. So there is your interval notation. Open bracket, 6, comma, infinity, parentheses. Two more. This is a heck of a section. 14. All right. Woo, so much. 5. Open, you know what? I'm gonna start. 5. Open parentheses, 2k plus 3, close. Minus 2, open another parentheses, k minus 8, close. Here's my symbol, greater than 3, open parentheses, 2k plus 5, close, plus k minus 2. It's a lot. All right, the first thing I'm going to do, again, since I have so much going on in front and behind my symbol, is I'm going to bring it down so I don't misplace it. I got all those parentheses I need to get rid of. So the next step is I am going to distribute to remove each parenthesis. So let's see, on this one, I'll distribute the 5. To get rid of this parenthesis, it's negative 2 that's bumping up against it, so I'll distribute the negative 2. On the other side, there's a 3 bumping up against this one, so I'll distribute the 3. So I'm going to get rid of all those parentheses on this next step. So again, you're just multiplying what's inside. So let's see, here I've got 5 times 2k, which gives me 10k. Plus 5 times 3 gives me 15. So there's that parenthesis gone. Here, I will distribute the negative 2. Negative 2 times k. Remember, when you multiply a number times a letter, it just hooks them together. So that's just going to be negative 2k. And then here I've got negative 2 times negative 8. Since it's a negative times a negative, it is positive 16. So got rid of those parentheses. Now do the same on the other side. 3 times 2k gives me 6k. Plus 3 times 5 is 15. There's no parentheses around this. So I'm just dropping these guys down. Plus k minus 2. Now, the next step is what's going to clean this equation up a lot. Because if you're looking where your symbol is, and again, I bring it down so you don't lose it, there's all kinds of like terms going on in front of it and behind it. So let's see, can I put some K's together on the front of the symbol? Here I've got a 10K and a minus 2K. Again, they're on the same side of the symbol, so just put them in the same basket. 10K minus 2K just leaves me with 8Ks. I can also put together, who can go with this 15? Is there any other plain numbers on this side? The 16. So I'm going to put the positive 15 plus 16 together, which gives me plus 31. So that cleans up that side a lot. I'm going to do the same stuff over on the other side. Let's see, who can I put with this 6K? Any other Ks over here? Well, here's 1. So if I put it with the 6K and put those together, I actually have 7Ks. And are there any plain numbers to put with the 15? Well, here's one. So I can put the 15 with the minus 2 since they're on the same side of the symbol together, which gives me plus 13. So that cleans it up a lot just by putting the like terms together. So now if I bring down my symbol, so now that I've put all my like terms together, I notice that I have K's in front and behind the symbol, which means I want to put those together, right? So if I've got a K here and a K here, I'm going to knock out the one on the right. So I'm going to subtract this 7K. Do it over here also. So let's see. Oh, here's good news. 8K minus 7K just leaves me with 1K, which is what I like to see. Bring down my plus 31. I still haven't divided by a negative, so my symbol is pointing in the same direction still. All that's left over here is 13. So I actually just have one more step, right, to get K alone. The only person that needs to go away is the plus 3, so I will minus 3. Get rid of that plus 3. So now K is by itself. My symbol points in the same direction.
Is that 31 or 3?
3. 31. Whoops, what did I do? Oh, I just didn't. Oh my gosh, thank you.
I was like, wait a minute, where did I go wrong?
You didn't go wrong, I did. So what I brought down 3 right here for some reason when I should have brought down 31, right? Is that what you're talking about? Obviously. So I need to get rid of plus 31 on both sides. So what am I doing now? Minus 31 on both sides. So the 31s cancel. There's my K all by itself. So over there I have 13 minus 31. I'm probably going to punch that in, which gives me negative 18. So on my number line, if 0 is here, negative 18 is on this side of it. Draw your arrow. Your arrow will go in the same direction as this symbol. I'm pointing my arrow in the same direction. These two things match each other. Negative 18 is going to have a parenthesis around it, right? Since it doesn't have an equal to bar. Arrows going forever to the right. Go to infinity. So again, there's your interval notation. Now that you see the number line, you just cheat and pull it straight off the number line. So open parenthesis, negative 18 to infinity and close.
These number lines are confusing me. Like A, C, and E.
Wait, say that again. The what, C and E?
The number lines. So A.
Oh, okay. Let's look at that. Okay,
Right.
so this one. here's what I would do first. Is this a parenthesis or a bracket? It's a parenthesis, right? Yep. So the first thing I would do is go through and cross out any one that is a bracket.
Okay.
So let's see, that would be D has a bracket. What's that? F has a bracket. So those both have brackets. That's only, oh, B has a bracket also, right? So that gets rid of half of them because I crossed out everybody that has a bracket. Oh, wait, F doesn't have a bracket. I can't see when I'm pointing it to y'all. So now you're down to that, right? Those are the two that have brackets. So they're gone. Now let's see, something else I can use is which direction does your arrow point? To the right, which means the ones that are left. So all of these, now I'm looking for anybody that has an arrow pointing to the left and crossing it out, which doesn't help me a lot. But that does get rid of F, right? Because its arrow is pointing in the wrong direction. So now I'm down to these three. Oh, man. I see what you're saying on this one.
Yeah.
So where should the parenthesis be on? Negative 18, right? So
yeah.
Let's see. Oh, this is awful. Oh, my gosh. So here's what you would do here. If these are negative 40s, and that's 0, that means each one of these hash marks is a 5. So that's negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, negative 40. But then I need to think, okay, where would negative 18 be in between? I'm going to draw it on here. If I drew that, let's do this one. I'm going to put that, I'm going to draw those on the board. So this is what the graph looks like. And it stops at negative 40. I mean, it goes on forever, but it's at negative 40. So let's see, this will be negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35, and negative 40. Negative 18 would be in between these two, right? Negative 15 and negative 20. So negative 18 would be about right here. Between negative 15 and negative 20. A little bit closer to negative 20.
A and C look really close between those two. I can't tell which one's a little bit closer, but
I mean, I see exactly what you're saying. That's ridiculous.
It looked like it's gonna be C because A looks like it's on the dot, and then C look like it's a little closer.
yeah, A's a little bit more in between the two.
I mean, that I can't believe that happened like that. The answer says C. So I think what y'all are saying is right. Between A and C, A is a little bit closer to the negative 15. C is a little bit closer to the negative 20. That's the only thing that distinguishes between those two.
Yeah.
So I think y'all are right. I think that's why it's C, because that would be a little bit closer to negative 20 than negative 15. Wow. I'll put a note on there to not put that problem like that, like where you can't tell hardly on the test. That won't be on there. Is that the only one that's been that hard to look at?
I think so.
Wow. So on the other ones, definitely the way I would narrow down that multiple choice stuff is, first of all, if it's parentheses, go through and knock out anybody that's a bracket. Narrow it down that way. Then after you take away all the brackets, then take away the ones where the arrow doesn't point in the right direction. Cross those out. Usually that gets you to it. Then you may have parentheses, like one will be on -18 and one will be on +18. Usually they just show it like that different, but I can't believe I hadn't seen this like number 14 before. Okay, last one. This is a word problem. It says John has grades of 86 and 98 on his first 2 history tests. What must he score on his 3rd test so that his average is at least 89? So let's think about what that means. So let's see, his first 2 scores are 86 and 98. And he's got one more test to take. Which means, I can't believe they're doing this. Hang on. Hang on, I'm gonna pause it real quick. I gotta make sure there's one thing I'm questioning.